During this session I'll be talking about relative velocity. It's quite straightforward if we're all thinking about motion as it pertains to everyone being in fixed positions. But for instance, if we look at the example in the cartoon here, it gets a little bit more complicated when one of the frames of reference is moving. In this case, the train is moving and the person is not, and they're being told to wait and hold still, and they're like, I am standing still. It's all about the relative velocity, and this requires us to think about what's required as a frame of reference. So relative velocity is the apparent velocity dependent upon a frame of reference, and we can select the frame of reference, and sometimes it's useful to interchange these frames of reference to allow us to do certain calculations. So I'm going to start with some basic examples, and I'm taking these from NASA. Okay. So NASA's got an example where they're thinking about how you work out the airspeed of a plane when you are standing on the ground. Now what you have to remember is, with the airspeed, what you're seeing is the speed of the plane. With the plane would have an airspeed plus, in this case, there's an additional wind speed, which gives you the total speed which you're observing from ground. So therefore, to work out what the actual airspeed of the airplane is, it's going to be ground speed, is what you're observing as the with your reference point, minus the wind speed, gives us the actual speed of the plane flying through the air. So that's with ground as a reference. Here I've got a slightly more complicated one. This time we're using the aircraft as the reference. So imagine that the aircraft is the reference point. Now here what we've got to think about is what's going to happen if you're imagining that the aircraft, which is from the ground, appears to be a moving object, but if we have that as our constant reference point, what actually happens is it looks like the ground is rushing away below us, and the air, and in this case the wind, are also flying towards us in the opposite direction. Okay. Now in this case, if we wanted to work out the wind speed, what I'd have to do is I'd have to subtract ground speed from airspeed to give me the wind speed. Okay. And notice how in this case the airspeed and the wind speed are going in the opposite direction as is the ground speed. So again, this is all just dependent on the reference which we choose to take. Here's an example question. There's a man on a train, and the train, with respect to the ground, is travelling at 10 meters per second. Whilst there's a man on the train, and he throws the ball relative to the train, is travelling at 5 meters per second. How fast is the ball travelling relative to the thrower? Well, the thrower and the train are existing in the same frame of reference. So that means that if we think about the velocity of the ball, it's going to be the same as the velocity with the ball and the train. So that means our answer is going to be 5 meters seconds to the right. Notice how I'm using velocities here. How fast is the ball travelling relative to an observer on the ground? Now what the observer on the ground would see that the train moving and the ball moving in the train. So what would have is a sum of 10 meters per second and 5 meters per second. It would appear to be travelling at 15 meters per second to the right. So be careful with your frame of reference. A great example of, I guess, relative velocities is often described when we're talking about boat problems. And here what we often find is that a boat is travelling across a river, but at the same time the river has a velocity travelling in another direction. So the boat has velocity of 5 meters per second with respect to the river, and its aim is to reach point A. However, the river speed causes it to end up at point B. If the speed of the current is 2 meters per second to the east, calculate the time of the trip and the distance between A to B. So what we've got to do here is we'll do some additional calculations. We recognise that although the boat wants to travel straight across, it actually travels a longer distance, so therefore we need to do some thinking about this. So the question asks us, calculate the time of the trip and the distance between A and B. So, how do we do this? First of all, if I want to find out the time of the trip, well, I need to just think about the vertical motion. So here the boat is travelling at 5 meters per second, and it's going to be travelling 40 meters in this direction. So the total time is going to be 8 seconds. Now, during this 8 seconds, the boat is also going to undergo some horizontal motion due to the river, and that's going to be a rate of 2 meters per second. So that means rather than going directly across to point A, it will travel a further 16 meters down the river. So there's some examples of questions involving relative velocity. I hope they're useful for you in the future.